Welcome back to Distributed Generation and Smart Grid Lecture Series. In this video, we are going to discuss about cloud computing for smart grid applications. A reliable and efficient communication system is required for the robust, affordable, and secure supply of power through smart grid. So the computational requirement for smart grid applications can be met by using the cloud computing or CC model. The flexible resources and services shared in network or parallel processing and uh, omnipresent access are some features of cloud computing that are desirable for smart grid applications. Even though uh, uh, the cloud computing model is considered efficient for smart grid, it has some constraints such as security and reliability. So the cloud computing is used to perform the communication process between substations and power supply system or power plants, and it can be cloud computing platform can be utilized for obtaining scalable, elastic, secure, and shareable resources in order to build and operate a functional smart grid architecture. So there are many applications of cloud computing in smart grid. This cloud computing platform chosen for smart grid application should realize high assurance in their communication systems. And over the time of the day, the resource requirement varies as the utilization differentiate between the day and night in case of our power system. So uh, cloud computing platform can be very useful for assuring the communication systems in that particular structure. So already we know that a smart grid NIST architecture and its various communication links. Already we studied various domains like bulk generation, transmission, distribution, customer, service provider, operation, markets, etc. And all these are interconnected through communication flows. So we can see that communication link between all these. So an electric grid with the information and communication technology is actually known as smart grid, and the grid which is enabled by ICT, information and communication technology, is known as smart grid. So information about consumers electricity consumption behavior is collected automatically with the use of ICT. So this helps increase the efficiency, reliability and performance of the electrical grid. So the two-way communication is a main part of a smart grid, and in that communication and storage technologies, we can utilize the cloud computing platform. So let's see what is cloud computing. So cloud computing have various definitions. You can see in your literature, various definitions are there. In Wikipedia, you can see that cloud computing is internet based development and use of computer technology. In concept, it is a paradigm shift whereby details are abstracted from the users who no longer need knowledge of, expertise in, or control over the technology infrastructure in the cloud that support them. So you can see some other definition by Thomas Bittman, that is cloud computing is a style of computing where scalable and elastic IT enabled capabilities are delivered as a service to external customers using internet technologies. Then you can see various definitions. You can see these definitions in your internet. You can generally define as cloud computing as uh, a set of applications managed and hosted externally by a specialist partner, delivered over a secure high quality network, available anywhere with an internet connection. So that is one of the good definition for cloud computing. That is, these applications are provided externally by a some service provider, and it is delivered over a high quality network, and it can be accessed at any time at anywhere using internet connection. Very simple example is that your Gmail, you are using Gmail that is provided by Google, and we don't know any technology behind it Gmail, and we don't know where our mails are stored, where is the location of their storage technology. Nothing. We are the consumer or customer is uh, uh, not at all worried about their technology and their storage locations, etc. So we simply access these services by logging into your credential using your internet at anywhere, any location. So that is a kind of a cloud service. We are not at all aware about our we all of you are using any type any Gmail or any kind of mail services, but we don't know what is the where is the location of our particular Gmail or Yahoo Mail, and it can be accessed at anywhere using an internet also. So that is a example of a cloud service. So a set of applications managed and hosted externally by a specialist partner, delivered over a secure high quality network, available anywhere with an internet connection. So applications maintained by expert partner, so they will be up to date. So no installation of hardware or software at your premises. No need to install a hard disk to store your mail or anything. So those things are stored in somewhere, and we are not aware about that. Then no specialist IT support required. No capital expenditure, and sometimes pay on a subscription basis. 50% reduction in total ownership cost. So there are various types of service providers and various types of agreements or payments. In general, Gmail is provided by Google is free up to particular storage space like a 15 GB. It is free. You can even you can use a G Suite email ID, Gmail ID also. That is a paid version. So cloud computing have three dimensions. That is, it is related with the essential characteristics, deployment models, and service models. So essential characteristics of a cloud are broad network access, measured services, on-demand self-service, rapid elasticity, resource pooling, etc. Then deployment models. This kind of cloud computing is can be different types of cloud will be there: private cloud, hybrid public cloud, then the combination hybrid cloud or community cloud. So we will discuss in the coming slides. So then the service provided by a cloud service provider this type of service can be a software as a service, or a platform as a service, or an infrastructure as a service. So an example, software as a service, the Gmail is a software as a service, example for a software as a service. So platform, you can give a cloud platform. So Android is a platform as a service. So like that, the service also you can differentiate it. So these are the three major building blocks of cloud computing. And what cloud computing isn't? It is not a networking computing where programs are hosted in a single company servers and accessed over the company network. It is not a networking. It is not traditional outsourcing where a company farms out its computing services to an outside firm. So it is not a outsourcing, it is not a networking. So cloud computing is something other than this. So you can see characteristics of cloud computing. Uh, Various characteristics such as reliability, uh, security, performance, agility, multi-tenancy, devices and location independence, API, low cost, virtualization. Each and everything we will discuss. Cloud computing characteristics. And the characteristics of cloud computing that can yield improved smart grid applications. Our interest is to find out the characteristics that can be utilized for smart grid. So these are reconstruction of smart grid technological infrastructure is provided with the agility characteristics of cloud computing. The communication between the machine and cloud service is done via cloud computing application programming interfaces. Public cloud delivery model provides the lower cost for smart grid customers. So any devices by a consumer or customer that needs to access the system can do this from anywhere via internet. This is the device and location independence feature of a cloud computing. So if any customer is a part of smart grid, he or she can access their various parameters such as their energy expenditure or status of their devices, etc., from anywhere, any location using cloud computing support. So maintenance and virtualization are other properties of CC. Installation is not required for running applications and performing the computations. This provides easy access to cloud computing services from anywhere at any time. Servers or storage devices can be servers and storage devices can be shared and carried easily from one server to another using virtualization property of CC. So there are various important properties of uh, cloud computing that support the smart grid. Then so large number of users use shared resources which are located in a pool. So this is enabled by the one of the characteristics known as multi-tenancy characteristics of cloud computing. So in this way, infrastructure is centralized with lower cost without needing extra devices, load capacity, and you can increase the utilization also. So multi-tenancy means large number of users can share the resources. And cloud computing actually provides the disaster recovery capability, and this assures the reliability. So disaster recovery capability means you can monitor the any outage from the power system very effectively, so that it can increase the reliability. uh, and some architectures are constructed for increasing the system performance in cloud computing platform by using web services. uh, and the reliability can be increased by using a cloud computing facility. And then opportunities to apply cloud computing in smart grid. What are the additional advantage when you are using a cloud computing architecture in smart grid? This you can see here is rapid response, central data storage, cost efficiency, security, and scalability. So here you can see scalability. Uh, Early smart grid applications are poor in performance because of the scalability problem for smart grid components that are employed on a large scale. Cloud computing solves this scalability problem by deploying the storage devices geographically and expanding them vertically or horizontally. So, in smart grid, you know that there are a lot of integration of distributed power generation. So, this distributed power generation may increase day by day. New distributed energy resources will be added to the smart grid. So those new introduction or penetration of a lot of renewable energy system integration occurs, we need to increase the data communication facility also. So that is that can be very well achieved using smart cloud computing, because cloud is easily scalable. You can increase the communication facility very easily. So it is very suitable to smart grid, where there will be large penetration of renewable energy based power production, and we need to accommodate those things also into the system. Then cost efficiency is one of the advantage. This information exchange is provided at a low cost over the internet by cloud platform, and dedicated lines are used in the for the smart grid. And then central data storage. Sufficient storage and performance can be provided by a single cloud data center with lower cost compared to deploying a special computing hardware. And if you are implementing data storage by purchasing hardware, it is very costly. So the cloud service provider can provide a data storage with a lower cost. Then data security and privacy are the most crucial issues for smart grid environment. So even if it is very much secure, there will be a security problem. So that is it can be put in your advantage or also in the disadvantage. Then real time response. Huge amount of data such as energy, control or consumption, and market data is processed synchronously by cloud computing with its distributed data processing centers, which provides a scalable load balancing technology in smart grid. So real-time response or real-time data can be obtained in cloud computing. So these are the various points we discussed: the scalability, cost efficiency, central data storage, security, and real-time uh, uh, response. Here you can see the opportunities and challenges of cloud computing for smart grid utilities. So we discussed the opportunities: security, scalability, cost efficiency, real-time response, and central data storage. And there are challenges also. So various challenges like data commingling, location of data, compatibility, disaster recovery, inefficient policies, API dependency, etc. are the various challenges in the cloud computing for smart grid. First one is the location of data. So cloud servers are placed in any location. So location of these servers that store and process smart grid applications are not known by the business enterprises. So this is very critical issue to meet the requirement of data management in smart grid. So therefore, defining the data location by cloud service providers has a vital importance for the security of smart grid applications. So when it is comes into the smart grid system, the datas are the consumer related datas will be there. So these datas are very important and very private data will be there. So this will be stored in the remote location. The utility don't have any idea about the storage location. So the security aspect or data lossage or data missing may be occur. There will be chances of some security problems in related to the data, as the data is located at various remote locations. Then mixing of data. This cloud computing enables a model to access the application through a location independent resource pool. So there are many multi-user application in CSP. That is, the same cloud may be shared to some other client also. So the same cloud is shared with some other users also. So there are the possibility of mixing of data. And however, the security and scalability of them is an open issue for enterprises. Therefore, some security methods such as data encryption algorithm must be applied in CSP for reliability and confidentiality in smart grid applications. Then inefficient cloud security policy. Some service providers apply weaker security policies than others. So these differences may be specific to utilities. Therefore, they may cause a disagreement between smart grid utilities. Then terms of agreement. If contract agreement included commercial purpose that process stored data in cloud computing. So smart grid utilities can pay huge amount of charge to CSPs for their requested data after service level agreement end date. So there will be some terms of agreement, and if a utility need some data after their agreement date, they need to pay huge amount. So still such kind of problems will be there. Then dependence of CSP's application programming interfaces. So this smart grid sometimes we need to change accordance with their application programming interfaces, APIs. So many applications in cloud computing are implemented by cloud service providers, and they are compatible with the utility specific APIs. So therefore sometimes some smart grid services in order to avail in order to accommodate the smart grid services, we need to change some services. We need to change according to the service providers, their application programming in based on based on their application programming interfaces. Smart grid services also need to be modified. And compatibility. Cloud computing does not comply any audit requirements. So this is the most critical issue that must be overcome by CC for meeting smart grid auditing compliance requirements. So smart grid actually will definitely require an auditing, and the CC does not comply in auditing requirements. So such kind of problems will be occur. Then redundant data management and disaster recovery. So recovery in emergency situation is the biggest concern in smart grid utilities, because CC cloud computing distributes data to multiple servers in different geographical areas. So the first point itself is the problem, that is the location of the data is distributed at different geographical area. So recovery of the data during the emergency situation is a biggest concern. So these are the some of the challenges. So there are challenges and opportunities for smart grid while we are using a cloud computing architecture.